we're going to start off. I'm going to share the book for the questions and answers. Before I begin, though, with the questions and answers, I want to remind you to get familiar with the units of measure and their prefixes for the metric system, because you're going to need them all throughout your ham radio experience. Everything we do is in numbers that are defined basically by the conventions of the metric system. So you're going to have to remember that a base unit times 10 is a deca, times 1,000 is a kilo, times a million is a mega, times a billion is a giga, and I don't know how many 10 to the 12 is by what word, but that's a tera. And the other way around, you're going to particularly have to know, for example, at 0.001, which is tenths, hundredths, thousandths of a whatever the unit is a milli, and that a thousandth of that is a micro, which is a millionth of a whatever it is, and a thousandth of that is a nano, and a thousandth of that is a pico. I don't know how they come up with these words. Well, I know a couple of them, but I don't know them all. But they're the ones that the International Committee of Standards they've defined them, and we get to use them. All right, let's move along. Why won't you minimize? Well, if you won't, I'll move you. So I'm going to, there we go. All right, we're going to go through these quick questions fast because they are what I just discussed. T5 B01 is the first question we're starting with. How many milliamperes is 1.5 amperes? Milliamperes is a thousandth of an amp. The answer is C, 1,500. If you multiply 1.5 times 1,500, you're going to get this answer. Again, that goes back to that chart. It's in your book, by the way. That chart is in your book. I don't know what it is, but it's in your book. You might want to make a copy of it and keep it handy. Which is equal to 15,000, I'm sorry, 1,500,000 hertz. All right. 1,000,000 hertz is 1.5 megahertz because it's a million. That answer is not here. A kilo would be 1,500 because you take off 3 zeros, or you divide it by 1,000, and that's the same as taking off 3 zeros. And so 1,500 kilos looks like the number is right, and that's the answer on the page, which is equal to 1 kilovolt. The number for the value of a kilo is 1,000. If you have a kilo of cocaine or a kilo of voltage, it's 1,000 whatever you got. So I never had a kilo of cocaine, and I don't really care to have it, and I care not to touch a kilo of volts. But a kilovolt is the answer. That's answer C, which is equal to 1 microvolt. A microvolt is a millionth of a volt. So you divide 1 by a million, and you get 1 millionth of a volt. Answer A. What is equal to 500 milliwatts? Well, 500 milliwatts, well, 1,000 milliwatts would be a watt, and you got half that. So my guess would be, if you did the math and you multiplied that divided that 500 by 1,000, you'd come up with half a watt. The answer is B. You guys all follow this so you know how to do these? Because they're really not going to go through every single one of them. But this is what you got to get familiar with. So you answer these questions, and they're very simple once you just know the values. So I'm going to jump ahead here. Which decibel value most closely represents a power increase from 5 watts to 10? This should always be easy. When you go from 5 to 10, you're doubling the power. And this one you don't have to do the math on. The math is below. You take log 10 times the value of 10 divided by the 5. And then if you solve that out, you'll come up with 3 dB. Log 10 of 2 is what you'll have. And that will, when you do the logarithmic calculations, will be log 10. But most of us don't have to do that because we know that 3 dB is a doubling of the power. Every 3 dB is a doubling of power. Every division or reduction by 3 dB is halving the power, or cutting it in half. Which most closely represents a power decrease from 12 watts to 3? This one gets a little more tricky. Okay. You can do the equation down below, but look, remember what I told you again. If I divide 12 in half, that's 3 dB. But at 12 and a half is 6 watts. And that 6 watts divided in half again would be 3 watts. That's what we're looking for. So I divided 12 and a half once, that's 3 dB. And 12 and a half, or 12 is divided in half again. That's another 3 dB, so it'd be 6 dB. I'm teaching the easy to get ways, guys, how to shortcut this. Okay. Which decimal value represents an increase in power from 20 watts to 200 watts? That's a little trickier. Because 20 watts, if you really want to do this right, you should use this equation, learn it and use it. But you can estimate it knowing what that every doubling is 3 dB. So if I want to go 20 and I double it, that's 40. That's 3. I double it again, that's 80. That's 6 dB. I double that 80 again, it's 160. I'm almost to 200, but I don't have enough to double it again. So at 9 dB, I'm a little bit short. So the closest answer in there is going to be 10 dB by interpolation. But if you really need it precisely, if they don't give you an answer if the answers are very close and you're not really going to be sure, this is going to be the time you have to do the equation. And it's log 10 times the power you're starting with divided by the power you're ending with. And that will give you a value. And then you have to use logarithmic tables or a calculator, and it will tell you 10. Log 10 of 10 is 10, by the way.
Do they let us have a calculator on the test?
Yes, you can have a calculator on the test. It can have scientific functions. It can even have scientific functions with programmable, but they're going to make sure you erased all the program. So that's what they're supposed to do. Which is equal to 28,400 kilohertz. Well, a megahertz is 1,000 kilohertz. So if we divided that by 1,000, we get 28.4 megahertz. That's answer D. Pay attention. You got 28.4 up here, but that's kilohertz. Well, that's going to be wrong because the answer in kilohertz is what's up here, 28,400. They're looking for another version. not the same, which is equal to 2,425 megahertz. Well, if we divide 2425 by 1,000, which is what a gigahertz would be, then we're going to get an answer of 2.425 gigahertz. And believe me, if you touch something transmitting at 2.425 gigahertz, it will be megahertz 1,000 times over. That's pretty much the frequency of a microwave oven, which describes the ability to store energy in an electric field. It's a little tricky. You store electricity in a capacitor. Storing it is capacitance. You store current in an inductor. You're storing it in a magnetic field. But this asks about in an electric field. So let's move on. What is a unit of capacitance? A unit of capacitance is a farad. 1 farad is a very huge device. About the size of a very large garbage can would make a 1 farad capacitor in the old days. Nowadays, we got some techniques for making them smaller, but they're still big. So you're going to be dealing with most capacitors and micro, milli, and even smaller ranges. You're going to be dealing with picofarads and nanofarads and picofarads. And so a millionth and a billionth of a farad is more common than I've never seen a 1 farad capacitor. Okay. What describes the ability to store energy in an electromagnetic field? Well, remember we just said that in an electric field, we're storing in a capacitor. I told you, in a coil, in an inductor, we're storing a magnetic field. That is inductance, D. And we're storing energy or current in that field. Okay. By the way, inductance is measured in henries. The values of inductors are in henries. Again, you will usually be dealing in very tiny values of henries. Okay. What is the basic unit of inductance? Well, I just answered that. C, it's a henry. What is the unit of impedance? Remember, I gave you the impedance formula already. Impedance is the combination of the square of the resistance, but the square root of the square of the resistance, plus the inductive reactance, which is that formula 1 over 2 pi FL, and it's the formula 2 pi FL, and the capacitive inductance 1 over 2 pi FC. Now, all of those units, inductance, are inductive reactance, capacitive reactance, and resistance are all in ohms. So you end up adding them together, adding the squares of them together, and then taking the square root. But they are the combination of reactance, which is composed of both the capacitive and the inductive reactance plus resistance. That's the definition of impedance. And the answer says the unit of measure is ohms. What does the abbreviation RF mean? It means radio frequency. So any radio frequency of all types are RF. What does the word radio frequency mean? Anybody want to guess? It's an electromagnetic wave pretty much above, above, I would guess, I would start with 1,000 hertz, but they probably go way lower because audio frequencies are 20,000. So Signals have greater than 20,000 hertz. So there you go, greater than 20,000 hertz or 20 kilohertz. And our radio spectrum as amateurs begin at roughly 1.8 megahertz or 1800 kilohertz. For the most part, we do have some ultra long wave experimental frequencies. But so that pretty much reflects where the ham bands are. Okay, so we'll move along. What is the abbreviation for megahertz? The answer C there was what we used to write it as, but it has been changed, and now it is the answer D. And capital M for mega, capital H for Hertz because it's a proper last name of a physicist, and the Z is the last part of Hertz. So it's small z, capital H, small z. That is the proper way to write it. What is the formula to calculate power? Remember I told you power is the I formula, or pi formula. P equals I times E. And that's answer A. We have the circle for that. Remember, guys? I'll pull it up at break, and before we start again after break, I'll review that. How much power is delivered by a 13.8 DC voltage of 13.8 volt DC and a current of 10 amps? Well, P is equal to E times I. We got 13.8 volts. You multiply it times the current, 10 amps, and you'll get 138 watts. The answer is A. How much power is delivered by a voltage of 12 volts DC and a current of 2.5 amperes? Again, you take that 12, multiply it times 2.5 because P is equal to I times, or E times I times E. It doesn't matter. I like to go IE because pi is a simple word to remember. I'm always hungry when I hear that. And you get 30 watts. 2.5 times 12 is 30. How much current is delivered by 120 watt voltage at 12 volts DC? Whoa. How much current is required to deliver 120 watts? Oh, at 12 volts DC. Well, okay. If P is equal to IE, you can use a circle to do this if you don't know how to derive the equations, but I is then equal to P over E. These two circles we talked about earlier. When you take your test, you can have a scrap sheet of paper. In fact, normally at testing centers, they give you one. So when you have a question like the one we just had in the book, which was if you have 120 watts of power at 12 volts, how much current are you going to draw? Or a problem like that, okay? You know you got this equation, P equals IE. Well, they gave you the power, okay? So draw yourself a circle. Remember the PIE, the pi formula, or the EIR, EIR. I'm sorry I don't spell EIR right, but hey, it works for this. These two equations, this is the simplest way to do it. If you know the power, if they give you whatever they give you, if they gave you the power is 120. So put that 120 watts up in the top right here. Let me grab it won't let me grab a drawing thing. It's got a thingamajigger in my way. All right, this is better. Okay, so this is still won't let me do it. Here we go. We pick a pretty color. So you got 120 goes in the power spot. Okay, if they gave you the voltage as 12 volts, put 12 in the voltage spot. Now you got your equation. 120 over 12, you do the math, and your answer is going to be 10. It's that simple. And it works the same way if you have of resistance and inductance. I'm sorry, a resistance and current problem. Let's say they say to you, hey, you have a circuit that's running at 24 volts. And they say, how, and it's drawing 5 amps. Well, 5's kind of tough, but let's go with 10 amps. Okay. So I don't have to do hard math, guys. It's not my day. Well, yeah, we can do 5. Say they give you 5 amps, right? Well, if it was, that's the answer. You divide 5 into 24. Now you can do it the hard way, but the way I do it is, well, 10 will go in there 2.4 times. 5's got to go in there twice that much. 2.4 and 2.4 must be 4.8. So the resistance must be 4.8 ohms. Because we're using this equation. You see how you can just draw a circle, make the 2 lines, and as long as you remember, if you're using the power formula, it's PIE. And you just put the numbers in for whatever P should be, whatever I or whatever E is, whatever you're given. Or if it is the resistance formula, or there was the general current formula, you've got E, that's where it goes, I, and R. Again, instead of putting these letters in there, if you want, you can go ahead and just draw them off at the side so you have to remember where everything goes. But EIR, ear, or PIE, and all you do is put the numbers in for the information or the values you've got, and it tells you how to solve for what. So if your power supply, oops, too far. If your power supply has to feed a 200-watt radio, you need to know how many amp of a power supply you should buy. I've already told you that you got 200 watts, but I already told you that amateur radios draw in twice the power they output, and they're rated in the power they output. So we're going to, in total power, we're going to be looking for 400 watts. And we know it runs on 13.8 volts. And if you grab your calculator out, you divide 13.8 into 400, and you got your answer. I got to grab a calculator to do this. Calculator. 400. You can't see it, I'm sorry. That's 29.98 amps. So I would buy a minimum of a 40 amp power supply, but you can get by with a 30. And 29.8 is squeaking it. I'd probably buy a 50. Okay. The reason we can do all this is because this is E. We were given the we knew the voltage because we buy a battery. We know what or we buy a radio. It tells us what voltage it is, tells us what current it is. We're trying to figure out the I. This is the I. And the same is true. I just said it. I did it backwards. I'm wrong. I'm going to stand correct. 400 volts, watts. Yeah, this is a P. I'm sorry, not the E. This is a P. That's what I did. This is the E. Did the numbers right, guys. Just put the wrong stuff in there for you. And I went old school with you. We used to actually memorize this equation as P equals AV. We actually went amps times voltage in the old days. I am old. Give me that break. So this is the easy way to learn to do it. I'm going to get back to the book. Is it clear? Is it confusing? Which is it? If you're comfortable with doing algebra and you can do the math, great. If you're not, use the circles. It's the easy way through. What is impedance? Impedance is the opposition of the flow to AC current. It's the total opposition to the flow of AC current. Answer A. So what is impedance composed of? It composed of the resistance plus the inductive capacitance plus the reactive, the capacitive reactance plus the inductive reactance. Now the formula is square root of the square of each one of those added together. But nevertheless, you don't have many things that will ask you that part of it on the test, not your test. What is the abbreviation for kilohertz? Same as the, pretty much the same as the um, gigahertz, except that the metric abbreviation for kilo is a small k. Capital K for the first letter in the word hertz, small z for the z from the word hertz. D is the answer. Ohm's law states, that one you should know. Ohm's law is E ear. E equals IR. They have rearranged it. If you can't do this in your head, then my suggestion is draw the circle again. If you do, you're going to have E at the top, and underneath it is going to be IR with a line in between. Put your finger over the I, and you're going to have the E over the R. Well, let me take a second to do that. Okay, I'm going to share screen. All right. We've got, let's not bother. Let's not do this. Let's make it easier on ourselves. Let's go to the actual equation. Draw the circle, but the EIR. But I would draw these on my page, right in the top corner of my scrap page. Now, if it asks you for the current, cover it up. The current is equal to E over R. If it asks you for the resistance is equal to E over I. If it asks you for the voltage is equal to E times R, the voltage of a circuit. Now, if you got to deal with a power formula, same thing. If they ask you, hey, what is the current in a circuit with X number of watts, that's power, and so many volts, that's current. So if they ask you to solve for current from power and voltage, again, you put your block off this one because that's what you're looking for. And the other two are the equation. P over E is equal to I. If you're looking for voltage, block that off. Imagine it's not there. P over I is equal to E. If you're looking for power, block that off. Power is equal to IE. I times E, pi. Pi ear. You guys remember that, right? You'll never forget. Promise me that. So we'll get back to the equations, or back to the text, I mean. All right. And they give you the same formulas, but I beat them to it. All right. It's just more of the same thing, and I'm going to keep going unless you guys want me to review more of it. I'm going to move on to a whole different section. These are all the same type of calculations. The only thing I want to point out to you is occasionally they might throw in one where the units of measures don't match up. And you have to take into effect or factor in the idea that maybe one is given to you in millivolts and one in mega ohms. Well, then you have to do the conversions because those equations only work right when the units are the even units. So you might end up having to do a 0.001 well, that's pretty small, but 0.001 ohm and times one or 0.15 amps to come up with a real tiny voltage, but they don't usually get that bad. But you got to pay attention, is what I'm trying to say, to the units. In which type of DC circuit is the current all the same all through the components? In a series circuit, the current is always the same. The voltage drop across each component will be determined by the resistance of each component. The total voltage drop will be all of the voltage drops combined, or the sum of the voltage drops. So the answer here is A. In a series circuit, they all share the same current through the circuit because it's a loop, and the current flows through the whole loop. Now, in a parallel circuit, it is multiple loops, and so they're going to be different. What electrical component opposes the flow of current in a DC circuit? In pure DC circuits, it is only resistance, only resistors that oppose the flow of current. Now, an inductor might oppose the flow if the material has a high enough resistance, but it won't be the inductance causing it. It'll just be the resistance of the material. So resistance is the only thing in a DC circuit. What type of component is used as an adjustable volume control? And it's old school. It was always a variable resistor. Another name for a variable resistor is potentiometer, and short for potentiometer, we call them pots, but they're looking for this answer here, potentiometer, because that's the answer they give you. What electrical parameter is controlled by potentiometers? Well, potentiometers are variable resistors. They control the resistance of a circuit or circuit path. What electrical component stores energy in an electric field? We covered this before. Energy stored in an electric field is capacitance, and the things that store capacitance are capacitors. So the answer is B. What type of electrical component consists of a conductive surfaces separated by an insulator? Well, that is exactly what a capacitor is. Two charged plates separated by an insulator. Answer is D. What type of electrical component stores energy in a magnetic field? Well, a magnetic field is formed when current flows through a wire, and if that wire is in a loop, it wraps around itself, creates a greater magnetic field, and that would be an inductor. By the way, even straight wires have some amount of induction. Not much, but some. In the microwave region, it becomes significant. In most others, it doesn't. So the answer here is C. What electrical component is typically constructed as a coil of wire? That's D, usually inductor. Okay. By the way, relays have a coil of wire, and they do have a portion that's an inductor, and that portion becomes a inductor strong enough with a magnetic field that's used to open and close the relay. That's the relay's coil. So it is an inductor, though. The coil part of a relay, the switch part is not. What is the function of a SPDT switch? Well, switches come in various designs, okay? This switch they're talking about is single, that's what the S stands for, post double throttle, okay? It is a single circuit between two other circuits. There's one switch, a single post thrown one way. It can go on or off. That's it. It doesn't have like an on, off, and another on the other way type of thing. But it can throw two throttles. There's two different contacts, two independent contacts. So it can turn on and off two different circuits, like two different lights, a light and a fan, lights and sirens on a police car. You can turn both of them on at once. What? By the way, a double throw, double throttle, a double post, double throttle would be. It has two ways it can post. It can post maybe center off, up on, and down another on, and then the double post is the same as before. If it's a single pole, single throttle, then it's just a switch and one contact. And they come gained in multiples. They can go up way beyond that. Those are just the most common switches. What electrical component is used to protect other circuit components from current overloads? The two devices that control that protect against current overloads are fuses and circuit breakers. And here, the only one they list is a fuse, so that's the correct answer. And it's not time, but I'm going to ask a trivia question, you guys. What's more dependable, a fuse or a circuit breaker? Who wants to guess? You guys think about it. I'll talk about it right at break time. Which of the following chemistries is rechargeable? All right, let's go through the list. Nickel metal hydride, lithium ion, lead acid. And the answer is D, all of the above. There are two types of batteries in general description, primary and secondary batteries. Primary batteries, when they're built, they have a lifetime chemical reaction. Once the chemical reaction is completed, it's done with. You can't do anything to fix it. Well, you can, but it doesn't work real well to recharge them. So you throw them away. And you know those are standard electrical batteries like flashlight batteries, AA batteries, AAA batteries, so on. They come in various chemistries, and they can also be bought in rechargeable versions, nickel metal hydride, lithium ion, lead acid. Oh, well, you won't find those. Well, they used to, yeah. Used to have C size lead acids. I don't know if they're still made. C and D size. But anyways, that pretty much answers that question. Which of the following battery chemistries is not rechargeable? Your standard old style battery is B, a carbon zinc battery. Once that reaction completes, the electrolyte paste loses all the energy and it's done with. Which type of component is in figure T2? Well, let's look at figure 2, T2. When we want to know which switch is represented in here. And there's just a single hole and a single switch point to this switch. If there was another switch point, there would be a dashed line and you'd see another switch indicating they had the same post, but only a but with a double throw. So it'd be a single pole double throw. But this one here is a single post, just one device, and a single throw. It only goes on and off, on or off. There's only one position you can turn on. That's a single pole. And there's only one thing that turns on and off. That's the throw. That's what you throw on or off when you work the switch. Does that make sense, everybody? You see see what we're referring to? Okay, we'll move along. Which is true about forward voltage drops in a diode? Okay. There's a barrier, a voltage barrier for every diode. It's less than a volt, but it's a small amount of current or voltage that has to be exceeded, not current voltage, before the diode conducts. So, which is true? Well, A, it's lower in some diodes types than others. That's correct. Because the germanium diode is a 0.3 volt barrier. It has a 0.3 volt barrier. Takes 0.3 volts before it will start to conduct. A silicone diode. You don't have selenium, thank God, anymore. Silicon diode will only start conducting after the voltage reaches 0.7 volts. By the way, that voltage of that threshold barrier voltage is a voltage drop through that diode. If you want to drop a voltage at 7/10 of a volt, you put a silicon diode in its path. If you want it to drop another 7/10 of a volt, you put another one. It's a constant voltage drop for every diode in there. It's a trick sometimes used to reduce voltages where fairly efficiently, I might add. Okay. What electronic component allows the flow or current to flow only in one direction? That is a diode. That is the purpose of a diode. Originally, diodes were a type of vacuum tube. They only allowed current to flow in one direction. They're the simplest of the vacuum tubes. Today, we use solid-state diodes. And which of the components can be used as an electronic switch? Well, of all these devices, a varistor is a form of condition-controlled resistance. Potentiometer is a variable resistor. And a thermistor is a temperature-controlled resistor. But a transistor can either amplify or be used as a switch. The difference between whether we amplify with a transistor or use it as a switch, when we wire up a transistor as an amplifier, we vary the input current so that it's within its linear range. but we do not fully saturate the resistor at its maximum capacity to conduct. So when we provide an input voltage to the transistor, the current through it is in an amplifier beyond the point at which it always conducts fully. Because an amplifier, we want it to go up and down with a signal coming in. And then the output will be greater because we're passing more power through the transistor than the amount we're bringing to bring the transistor to the state to conduct through the transistor. Now, when we use it as a switch, we provide either no voltage or the saturation voltage. The level at which, when we put that much power on the transistor, everything passing through the transistor is at its maximum value. Then it acts as a switch. Which of the following components can consist of three regions of a semiconductor material? And transistor, trans is from the Greek anatheotria. The Greek word tria is where trans comes from. And a transistor is a three semiconductor device. So the answer is B, transistor. Covered that when we covered transistors and diodes. Which type of transistor has a gate, drain, and source? I don't think I covered this fully with you guys, but that would be a field effect transistor, whether it's a MOSFET, which is metal oxide field effect transistor, or a JFET, which is junction field effect transistor, or CMOSFET. There are, whatever it is, the letter FET stand for field effect transistor, and they have instead of having anyways, they have a gate, they have a drain, and they have a source. Source travels through the field effect transistor. The source current or voltage travels through the current, travels through the drain source to the drain, controlled by the gate. It's pretty easy to visualize that. How is the cathode lead of a semiconductor diode often marked? The cathode lead is the negative side of anything. And the cathode lead on a diode will have a white stripe, a ring around it on that side of the diode, so you know which direction the diode has to be put in circuit. There is one exception to this. The Zener diode, which is a voltage regulating diode, always goes in the circuit backwards. It's designed to regulate by taking advantage of its breakover barrier, and it's utilized in reverse so that it can regulate voltage. Current doesn't really flow through it because of this. It actually flows in spite of it, or in a way you can think of it as around it. And so the excess is what travels through it. It's a complicated thing if you don't understand the theory. We don't explain it. They never do. Just know those exceptions for now. Believe me, even some electrical engineers don't fully understand that concept. All right. What causes a light emitting diode to emit light? I don't really like this question or the answer, but it's a technically correct answer. The forward current through the diode allows it to light. Diodes are very efficient. They don't need a lot of current to go through them. In fact, you'll burn them out if too much current goes through them. So almost all circuits involving diodes have current limiting resistors. But it is the flow of current in the forward direction that allows an LED to light. In the reverse direction, it's a diode, and no current will flow. It will not light if you wire a diode backwards. What does the abbreviation FET stand for? And I covered this already. Field Effect Transistor. Answer D. What are the names for the electrodes of a diode? Well, there's an anode and the cathode. And which of the following can provide power gain? Well, transformers, the power remains the same. The voltage or the current can be changed, but when the voltage goes up, the current goes down. So the net effect is proportionate. The net effect is that the power is always identical. Transistors, though, can amplify. Remember, we can use them either as amplifiers or switches. So they can provide gain to power, and that answer is B. Resistors reduce power, and reactors reduce power. Reactors is another name for inductors. What is a term that describes a device's ability to amplify a signal? And we define, or that term is gain. Gain is a measure of how much amplification is occurring. So if we have a 3-to-1 gain, then for every watt in, you've got 3 watts out. Gain can be measured in dBs. If we have a 3 dB gain, well, then if you have 100 watts in, you've got 200 watts out because 3 dB is double the power. But the general term is gain. What are the names of electrodes of a bipolar junction transistor, standard earliest design of transistor? And they have an emitter, a base, and a collector. You remember the FET has a source, a drain, and I'm drawing a mental blank, gate. Well, bipolar transistors have an emitter, a base, and a collector. The collector brings the power in, it travels out through the emitter, not necessarily, that's not necessarily the electron flow, and the base is what controls it. In an FET, it is the gate that controls the source power going to the God, I'm doing terrible, guys. Bear with me. I just can't. I'm drawing a mental blank. I'll pull it up for you. I'll have it for you. I'll have this drawn out, written up for you guys, so you won't lose. And I'll have it with the drawings of the 2 types. It's not important for you for the most part, except for the exam. Oh, okay. What is the name of electrical wiring of an electrical wiring diagram that uses standard component symbols? And standard component symbols are drawn in electrical schematic diagrams, and there is a uniform set, and it's in the book. At least some of them are in the book. Believe me, there's an infinite variety almost. And there isn't a single day in my life that doesn't go by when I find a new component. I have to go on the internet and say, what in the world is this? That's how many there really are. Fortunately, you don't. The most common ones are the ones you most see, and you'll almost never see the rare ones. What is the component in figure T1? Well, I don't know. Let's go look at figure T1. Will it let me? There it is. Figure T1. All right. Now, what was that question? I don't know which component. Let's go back.
Component 1.
What is component 1? Right? Boy, I'll tell you, some days it just doesn't want to cooperate. There we go. All right, anybody want to guess what component 1 is? Component 1 is a resistor right here. Okay. Component 2 is a bipolar transistor. Base, emitter, collector. Okay. Signal comes into the base, it controls how much flows out. Now you're saying, wait a minute, that's ground. How does it control what flows? Well, electrons go the other way around, right? They go from negative to positive, right? Doesn't matter which way you think of it, but the truth is the base controls. If this were this is an NPN right here because it's pointing out, that's negative. If the arrow was pointing in, it would be a PNP transistor. And then this side would be wired to plus and the battery, okay? And then the other side of the bulb would be wired to ground. And it would work the same, except things flow the opposite way. So let me go back. Oh, I could have got there the easy way. What is component 2? And we already covered that. Component 2 is a bipolar transistor. It's a transistor B. What is component 3? I don't remember off the top of my head. Component 3 is a light bulb. It's an incandescent bulb. Well, they call it a lamp. Sounds good to me. What is component 4? And I believe component 4 was the battery. Yep, that's the battery. Okay, I want to go back to that for a second. Pay attention that a battery is kind of like a capacitor drawing, but with little sections in the middle. It's like a capacitor would be just a couple plates, but there'll be a couple other plates. It's because the word battery means multiple of the units. Batteries are made from battery cells. In general, a battery has multiple cells. And so we kind of depict that that's that, so we know what we're talking about. The reason this is because generally a cell, a battery cell, is only about 1.5 volts. So we have to put them in series in order to get more voltage. And inside the battery pack, there are multiples. Inside the battery package, an individual battery, there are multiple cells inside, unless they're 1.5 volt batteries. If you take apart a 9 volt battery, you'll find like 6 batteries in there. If you take apart a 3.5 volt a 3.5 volt or battery, like a button battery, you'll find there's actually 2 buttons in there. They're 1.25 volts a piece. All right, let's move on.
Hey, Nick.
Yeah.
Maybe we could get Tom to bring his lithium-ion battery back in and we can take it apart and see how many cells there are in it.
Okay, you do the taking apart part. All right, let's look at figure 2, and I'm just going to go over figure 2. We're going to just cover all the components, okay? Here's figure 2. Component 1 is the electrical plug. Component 2 This is a symbol for a fuse. Component 3, this is a switch. This is a single post, single throttle switch. Component 4 is a transformer. Component 5 is a diode. Component 6 is a filter capacitor. It's a capacitor to filter out the ripple of the half-wave rectifier this single diode is making. Component 7 is a limiting resistor, limiting current through a light emitting diode. This is a light emitting diode. Component R2, which is 9, is a variable resistor or a potentiometer. That's the name of a variable resistor. It is controlling the current through this weird one. This is a Zener diode. Note that this diode's facing the wrong way for all the other circuits. By regulating the current through this Zener diode, it will pass through the opposite way, so to speak, all the excess voltage that does not need to go out. Zener diodes are built when you buy them, they're by the voltage value. So if you need to regulate a 6-volt circuit, you get a 6-volt Zener diode. If you control the current just right, that diode will regulate the output very, very well. If a current capacity that you need is greater than that one diode, then you amplify it with a bunch of transistors. They're called pass transistors when you do that. And that is what that sums up the most complicated power supplies in the world. A Zener diode provides a reference or regulation. Sometimes they use some ICs that are regulatory chips, but inside the regulatory chip of the IC is a series there's a Zener diode doing the trick. And then transistors actually can be used to increase the current in of the output as amplifiers. We call them pass transistors, but they're actually amplifier. They're just increasing the value of the current capacity of the circuit. I'm going to go through T3. T3 is actually an antenna tuner. Okay. It's a very simple device. A manual antenna tuner has an input. It goes into the input variable capacitor, a tuning capacitor. This one has a tuning coil, but sometimes they're switched to go in different positions here. This is an inductor going to ground. And then there's another capacitor, and that capacitor is the output or antenna tuning capacitor. Basically, you get the lowest SWR reading you can with the inductor. You move it till you get the lowest it'll get. And then you fine tune first the input and then the output capacitors until you get it to the axis. You actually go back and forth with those two until you get to the point where you get to the absolute lowest SWR, which is the forward to reverse ratio power. You want the most power forward, the least power going back at your radio. And that's how you use an antenna tuner. And this is the components. 2 variable capacitors. The input is going to be from your radio. The output is the antenna here at the end. That's 4. And 3 is the inductor, the adjustable or variable inductor. Okay, the thing to know about electrical schematics is that it only tells you the components and their connections. It does not tell you what the length of wire, what doesn't tell you physically where the components are. It doesn't tell you what the components look like. It's just a diagram of the electronic components and their connections. And essentially, it's just telling you how they're hooked up to each other. So you really have an identification of what the components are and how they're connected. Answer C is the correct answer. Okay. Which of the following devices or circuits change an alternating current into a varying direct current signal? The only device that changes AC to DC is a rectifier. Now, there are fundamentally most rectifier circuits are diode circuits, but there are exceptions. Because we can saturate a transistor and use it as a switch, you can also use transistor switching rectification. And that's what's done in switching power supplies. But either way, only a rectifier circuit converts AC to DC. What is a relay? Well, a relay is a electromagnetic controlled switch. There's a coil, power is applied to the coil. The coil causes mechanically a metal piece to move and make the contact to turn on and off the relay. So A is the answer. An electrically controlled switch is a relay, and its function is so that you can either have some other electronic devices turn on and off something of greater power that requires greater power than the switch might be able to handle, whether it's a mechanical switch or an electronic circuit, or if we need a remote device that we want to turn on and off somewhere far away, and that's what a relay does. Which of the following is a reason to use shielded wire? You use shielded wire to prevent the coupling of unwanted signals to or from the wire. Answer C. It's a confusing way of saying the stop signals from getting into or getting out of the coax. We want them to travel along the coax. So to prevent coupling of unwanted signals in or to or from the wire is answer C, and that is the correct answer. Which of the following displays an electrical quality as a numeric value? Okay. Which of the following displays an electrical quality as a numeric value? Well, I don't like this answer, but the answer is C. Okay. A meter will show you a value for it will give you an electrical value. It might be measuring current, it might be measuring voltage, it might be measuring all sorts of things. But you have to interpolate dial meters where they've got a needle moving back and forth. But that is an indication of a value. When they throw in the word numeric, I would say then you have to say a digital meter, but they don't ask for that. They're not that specific. So whether it's digital or analog, whether you have a digital display or a needle that moves, swings usually from right to left, meters give you an indication of a value. What type of control circuit controls the amount of voltage from a power supply? The circuit that controls the voltage is a regulator, a voltage regulator. And we need regulated power supplies because when you apply a load to a simple power supply, the greater the load, the more the power supply will drop. You need consistency in electricity. If you don't have that in radio, you don't have a consistent output reproducing the audio or the digital or even Morse code. It it fails, it suffers if you don't have a constant regulated power supply. What component changes 120 volt AC power to lower AC voltages? And you can raise or lower voltages with a transformer and only with a transformer. You can increase the current with a transistor. You can change the phase relationship with a capacitor. You can't really change much of anything but limit the direction of current flow with a diode. Which of the following is commonly used as a visual indicator? And the choice there is an LED, FET, Zener diode, or bipolar transistor. Well, you can't see any but the LED. And visual means you can see it. And LED is a visual indicator. It's on or it's off. And LEDs are also used as visual indicators, giving values because they can be on and off in segments that can display a value. But it requires more circuitry than a simple LED. Which of the following is combined with an inductor to make a resonant circuit? Resonant circuits have an inductor and a capacitor to tune to the resonant frequency. They're paired so that the capacitors, XML of the capacitor, the reactance of the capacitor is equal to the reactance of the inductor. Answer D. What is the name of a device that combines several semiconductors and other components into one package? And that would be an integrated circuit, an IC. ICs have multiple electrical devices inside. They can have multiple transistors, multiple inductors. They can have multiple capacitors. They can have multiple resistors. There are even ICs that have multiple LEDs built into them. Whatever device they want to throw in, the designers can do it. Sometimes it's not practical to do some or another, but the entire radios now exist, transmitters and receivers on individual integrated circuit, and the whole shot and caboodle's inside that chip. So, what is the function of component 2 in T1? Okay, we're going to try to find T1. Is it on the next page? No, it's not. Whatever it is, I'm pretty sure we covered it. We went through T1. There we go.
I think it was resistor.
Okay, we're on T1. What was it? I forgot what the number was.
Hang on. I've lost it now.
Okay, resistor. 1 is a resistor, 2 is a transistor, 3 is a incandescent light bulb, 4 is the battery. Is pretty simple. So let's go back. What is figure 2? Well, figure 2, I believe, was the transistor, was it not? 1, 2, transistor. There's a bipolar transistor, real quick. What type of bipolar is this, NPN or PNP?
I'm sorry. Would you throw that at me again? I was rereading the question because the answer didn't make sense with what we just said. So
I'll get back to it, but what type of transistor is this? A PNP or an NPN? If the arrow points out, it's a
It's
P, it's an NPN.
NPN. Okay. Out's
If
an
the
NPN.
arrow points in, it's a PMP. The difference is that if the arrow points to the negative direction, so pointing out, it's NPN. Pointing in, it's pointing to P, PNP.
Okay.
So to make a NPN work, okay, you got an NPN, right? So you got to have a positive voltage to make that switch on. A PNP is the opposite way around. Does that make sense? Because
Yep.
everything flows backwards from the NPN. They have advantages. There are times when you need one or the other. Okay, let's go back and look at the question. What is component 2? And what is the function of component 2?
Yeah,
And
I think
the
we read
answer
that as
should be
what is
C.
component two, not the function.
Well, it says what is the function?
Yeah, but I think when we read it and went back to the diagram, we were thinking what was
Yeah.
it, and it's the function.
It's the
So that would
function,
be
and the function of a transistor is to control the flow of the current.
flow. Yep.
So, okay. Which of the following is a resonant or tuned circuit? An inductor and a capacitor in series or parallel. Right there is the answer. Tuned circuits, depending on how they're applied and what they're used for, will either be an inductor and a capacitor in parallel or in series, or there will be multiple capacitors and multiple inductors, or any combination thereof in series or parallel. Okay. Where are we at? Okay. Which term describes the ability of a receiver to detect the presence of a signal? This is important. There are two main things you always want to pay attention to in receivers. One is selectivity, the other is sensitivity. And we're going to define them both as in this question. The thing that determines the receiver's ability to detect the signal is sensitivity. Sensitivity is how weak of a signal can it detect. Selectivity is how well can it discriminate or segregate one signal from another. Can you grasp the difference there? So selectivity is there are more than one signal on the air at any time across the radio spectrum. How close the signals and how easily the receiver can separate them, or how well it can separate them, and distinguish one from the other, is selectivity. How weak of signals it can receive is sensitivity. You can imagine why both of those are important. What is a transceiver? Well, a transceiver is a device that combines a receiver and a transmitter. That's why it's transceiver. And the drawing down here below, this basic station, this is how all radio stations used to be. You used to have a transmitter, a receiver, and a transmit receive switch. Mm-hmm. And you actually had to throw the switch from transmit to receive. The switch would turn off the receiver, turn on the transmitter, not the whole circuitry, but just its main function. It would switch the antenna from the transmitter to the receiver, depending on whether you're transmit or receive. Now that's all built into a transceiver. When you push the talk button, it does all this for you. Which of the following is used to convert a radio signal from one frequency to another? I covered this. This is the mixer. Special type of mixer that combines your audio and with the fundamental frequency to carry the information in your audio is called a modulator. And an AM or single sideband radio. In FM, it is also a modulator. It's an FM modulator, special type of mixer. Special because of its use. The difference between the two, the AM modulator controls the amplitude of the signal, so it controls the output power. The FM modulator controls the input oscillator, and it varies the voltage, or varies the frequency, I mean. Which term describes the ability of a receiver to discriminate between two signals? Remember, I told you that's selectivity. How we can select which one is which. What is the name for a circuit that generates a signal at a specific frequency? And that is an oscillator. It makes a specific frequency of signal. And then we can manipulate that to our advantage by mixing up the other signals or filtering out what we don't want. What device converts RF input and output of a transceiver to another band? I don't know if I covered it in the class, but I'll tell you, we have devices we call transverters. They're designed so that, let's say you have a 10-meter radio and you want to be able to operate on 2 meters. Well, they actually make, you can buy a circuit board, or you can build them yourself, that are transverters. They take the frequency of 10 meters on transmit and they mix a frequency in so that whatever frequency you're on in 10 meters proportionately is going to be on some value on 2 meters at 144 and above megahertz. So essentially, you could convert one radio to be used on a different band this way, and it does the same on the receive frequencies. But on the receive frequencies, okay, we generally refer to those as receive converters. Now, we also generally accept that a device that has both to work with a transceiver, we refer to those as still as transverters. Okay. What is the function of a transceiver's push to talk button? Well, it does what I told you earlier. Its function is it switches the receiver to receive, or from receive to transmit when it's grounded. That is correct. When the push to talk switch is grounded, the transceiver switches from receive to transmit. When it's not grounded, you're in receive. And in the process, it switches the antennas at the same time, the antenna from transmit to receive or receive to transmit. Which of the following describes combining speech with an RF carrier signal? And that would be modulation. Talked about special type of mixer called a modulator. And modulation is a means by which we mix the electronically reproduced audio sound. We convert it into an electrical wave at an audio frequency. We combine that with an RF wave through a mixer, and the combination is what carries the information for us. Information being what we can reproduce as speech. What is the function of the sideband CW/FM switch on a VHF power amplifier? This is a little confusing. Sideband and CW and FM have to be amplified a little differently. And there's a little circuitry that they put in power amps. And either they have an automatic circuit to do this, or you have to throw a manual switch. If you're using on sideband CW, you put it in the sideband CW side. If you're using it on FM, you put it on the FM side. AM would be in the same as the sideband CW. And what it does is sets the amplifier for the proper operation of the selected mode. Should be kind of self-explanatory, but the explanation there is not adequate. I'll tell you now, it's rather a complex thing altogether. Take my word for it, you just throw the switch and leave it wherever it should be. What device increases the transmitter output power from a transceiver? That would be B, an RF power amplifier. Where is an RF preamplifier installed? And it is installed between the antenna and the receiver. It pre-amplifies what's coming from the antenna to the receiver before it gets to the receiver. It amplifies everything that the antenna has and all the noise it has with it too. So there's a limit to how much pre-amplification you want to do, because at some point you'll amplify more distortion than you will signal you want. But on the other hand, you amplify everything. What you're doing is you're making the values of the voltages higher, and that means the receiver does not have to be as sensitive. So effectively, it makes it look as if the receiver is more sensitive than it is. I'm going to cover this one and we're going to be done. What can you do if you're told your FM handheld or mobile transceiver is over deviating? Over deviating is caused by over modulation, too much audio, to make it mildly. Because of that, because of the over modulation, your frequency from your FM signal is moving high and low beyond the range that a receiver on the other end could hear. So, what you want to do is reduce the intensity of the audio. And the tip D is a good one. Talk further away from the microphone. Talk softer. I don't know what you do with your big stick, but talk softer.